Hello. In the previous video, we learned that a continuous variable has no probability on a single point. So we have to define the probability using the cumulative distribution function instead. And let's think about an example. And now, X, we are going to consider a tall size coffee. So you order a coffee of a tall size and then measure its amount. How much, like, measure it with a super accurate scale or measurement. Then and then you, like, from many experiments, repetitions, you get the CDF. The CDF, suppose that the CDF is known at 3 points. So F11.9 is 5%, F12 is 30%, F12.2 is 90%. It means that the probability that a tall size coffee contains less than 11.9 ons is only 5%. And probability that a tall size coffee contains 12 ons is only 30%. Smaller than 12.2 ons is 90%. So from these informations, we will study if we can calculate different type of probabilities. For example, think about this. What then, given these three informations, what can you find the probability that a tall size coffee contains more than 12 ons or not? Think about this. Um, the answer is yes, you can calculate. And the idea is that here we have probability smaller than 12 is 30%. Then obviously probability greater than 12 is 70%, right? So smaller than 12 is 30%, and greater than 12 should be 70%. That's how we utilize a cumulative distribution function. Graphically, it can be written in this way. So we have 100% on the whole interval. Whole interval contains 100%, but smaller than x is the CDF. Then on the other side is probability greater than x, and you may understand it as a length. If you understand the probability as a length, as we studied in the previous example, this length, the length of this interval, is the whole interval length minus the left side interval length. So probability wise, you may write it this way. It's a complement rule. These two are complements, so you may write it this way. By the way, it's inequality, strict inequality, weak inequality do not matter, right? I may switch between them because including 1 point or not does not matter. So you don't need to worry about whether you are using strict or weak inequality. So therefore, probability greater than 12 is 100% minus 30%. This part we have the information, right? So even if cumulative distribution is defined as probability smaller than a number, still you can calculate probability greater than the number, right? It's simple. And then try this. So again, we have the same CDF information. Now we are looking for probability between these two numbers. Can you calculate? Think about this and try this. What is the probability that tall size coffee contains 11.9 ons, more than 11.9 but less than 12.2 ons? Try this. Think about this. Of course, you can calculate this, and the answer is 85%. Because let's think about this. Again, easy to understand on a graph. Now, as I said, understand the probability as a length that they are, and in this example, you may understand them equivalently. Or say the whole interval is from here up to here. So starting point and ending point, minimum and the maximum. But we have two informations. Probability smaller than x is the length here, and probability smaller than y is the length of this interval, right? As I said, probability, you may understand probability as a length. So, and we are interested in the probability length between these 2 points, this interval. The length of this interval is obviously the larger length minus the smaller length. The difference between two intervals length is this length. Mathematically, you may write it this way. Probability between 2 points is the probability that probability smaller than the larger number. Y is larger, so smaller than larger number. So all of these guys, and you have to subtract this much. Subtract probability smaller than x. And now the point is you have probability smaller than y, probability smaller than x, which are known. So when you have the cumulative probability distribution, then probability smaller than something is known. So always, even if the probability you are interested in is not in the same form as the CDF, but you can manipulate this interval, probability on an interval, as a difference of two CDFs. So again, the point is, if you know the CDF, then you can calculate any probability. We calculated a probability on an interval and probability greater than something. And of course, probability CDF itself is probability smaller than something. So any type of probability can be calculated using the CDF. That's what we meant, and that's why the CDF is the main tool to define the distribution, probability distribution. Okay, now we are going to connect this approach to the length approach. So at the beginning, I introduced the length as a way to understand probability, and then later I used the CDF. Then what's the relationship between them? Actually, the length is not a complete way, not an ideal way to capture the probability, because in this example, using these three numbers, you can see that probability between 11.9 and 12 is 25%, but probability between 12 and 12.2 is 60%. So the latter interval is twice longer than the earlier interval, the former interval, but the probability is more than twice, more than double, 60% and 25%. So in this simple example, the probability is not proportional to the length of the interval, right? So there are two intervals. If you calculate two intervals, their probabilities are not proportional to the length of intervals. So the previous length approach is not applicable in this example, or the length approach is not general enough to some examples. So we are going to consider a generalization of the length. That is, and I'm going to stop this video here, and we are going to study a more general approach in the next video. See you in the next video. I'm going to continue in the next video.